Okay then. So sequence and series, it's an easy and scoring chapter for NDA maths. First of all, let's talk about sequence. So sequence is a sequence of number where numbers are arranged following a certain order according to some rule. Okay, like numbers will be arranged. So the sequence we are going to look forward is of natural numbers. Natural numbers. Also, we define a sequence as a function whose domain is a set of natural numbers or some sets of the type 1, 2, 3, 4, 5, 6. Okay, so it's like an arrangement of numbers in definite order according to some rule, and that can be called as a sequence. Simple arrangement of numbers in certain order following some rule. Arrangement of numbers in certain order following some rule. Clear? A sequence containing a finite number of terms is called a finite sequence. So this is a sequence, and if we define this set, okay, so in this set there are a sequence of multiples of 2 from 1 to 10, right? Multiples of 2 with 2 is getting multiplied from 1 to 5. Okay, so there are finite elements in this set. So finite number of terms. So this particular sequence will be called as finite sequence. This is not a set. Sequence is a sequence. Yes. Am I audible?
Yes, sir.
Okay. So let's now discuss. A sequence is called infinite if it is not a finite sequence. If we say that multiples of 2, okay, and this is going ahead, there are not finite terms in this sequence, then it is an infinite sequence. So let's say this sequence 3, 5, 7, 9, 11. This is a sequence given by the rule. Rule is T of n is equals to 2 into n plus 1, where n is natural number. So starting from 1, so if you find out first term, then 2 into 1 plus 1, that becomes 3. Second terms, 2 into 2 plus 1, that becomes 5. 4 plus 1 becomes 5. Similarly, 3, 5, 7, 9, 11, all of them will be having difference of 2. Okay, so this is a sequence following, it is in a certain order following some rule. Okay, and this is the arrangement of them. Clear? This is a sequence example. Any doubts?
No, sir.
And if we add all of the sequence 3, 5, 7, 9, but that sequence has to be infinite for that, then we call it a series. If there are A1, A2, A3 be the sequence, then sum expressed as E1 plus E2 plus E3 is called series. A series, and now the series, it is not a necessary condition that we can find out the series of finite sequence only. We'll be able to find out the series of infinite sequence as well. A series having finite number of terms in it, like a series of finite sequence is known as finite series, otherwise infinite series. Clear?
Yes, sir.
Now we are going to look certain kind of sequence. First will be arithmetic sequence, and that is also known as arithmetic progression. Another one is geometric progression. Acronymed as AP, GP, and another form harmonic progression. Its short form is HP. Okay. So now let's first discuss about arithmetic progression. So this is a simple, it's a sequence of numbers. But the property what sets it apart from sequences having same or equal difference between terms of the sequence. Means if the sequence is A1, A2, A3, A4, okay. So the difference between those two consecutive terms, difference between two consecutive terms is always the same, is always the same. So if I say the difference between A1 and A2, the difference between A2 and A3, the difference between A3 and A4 should always be the same. Okay. And if it is the same, we call it as common difference. Okay. So let's construct an example by ourselves. One, this is a GP having its first term as, so this is an AP having its first term as 1 and common difference as 2. So the common difference is represented by D and the first term of AP is symbolized by A. Okay, so here our first term, here our first term is A and let's consider D is 5 plus 5. So if the difference between the two terms has to be 5, so it is increasing by 5. 6 plus 5 becomes 11. 11 plus 5 becomes 16, 21, and 26, 31, 36, 41, 46, 51, 56. Now we may observe that the difference between these two are is what? What is the difference between 6 and 1? What is the difference between 6 and 1? Hello.
Sir.
What is the difference between 6 and 1?
Is it 5, sir?
Yes, it is 5. What is the difference between these two terms?
5, sir.
These two terms?
5.
Yes. So everywhere, wherever we see any two consecutive terms, there is a difference of 5. That is why it is an arithmetic progression. So the one property which defines which makes a progression, an arithmetic progression, that is the difference between two consecutive terms is always the same, and which is known as common difference. So in AP, we need to know two things. First term symbolized by A and the common difference. Okay, so let's say we can say if there is a first term A, then the next term will be what? A plus common difference. And now the difference between these two is what? What is the difference between these two terms?
Um, is it D, sir?
Yes, it is D. A plus D minus of A becomes D. Now the difference between the next term should also be D. So meaning it would have to increase itself by 1D. So A plus 2D. Now the difference between these two is what?
D.
Yes. So A plus 3D and the AP will progress like this only. Clear? So this is first term. Do you agree?
Yes, sir.
So let's write the first term in this method, t representing term and 1 representing number. So we are going to represent the general term of AP as t of n, where n is the number of term and t is representing term. So t1 is here a, right? What is t2 here? A plus d. What is the third term here? A plus 2d. What is the fourth term here? A plus 3d. So we may observe that the first term is a plus 0d and the second term is a plus d. Now we may observe the relation between the number of elements and the coefficient of d. Now here the coefficient of d is 2 minus 1. The coefficient of d here is 3 minus 1, that is 2. Coefficient of d is here 4 minus 1. Yes. So if this is first term, no common difference will add it to the first term. If this is the second term, then one multiple of one common difference will be added. So from this we can conclude that if there is an nth term, okay, if there is nth term, then how we can write it? That a will getting added to the number of element minus 1 and minus 1 into common difference. So this should be the nth term. Clear? Any doubt?
No, sir.
Yes. So from the AP's observation, we have found it out that to finding out the nth term, like from this formula, as we have this formula now. So Tn is a plus n minus of 1 into d. So what is the 10th term? Can you tell me? What will be the
A
10th?
plus 9D.
Very good. What is the first term? Right,
A
right.
plus D.
A plus 1 minus 1 into d.
Um, so
0
A.
into 2 becomes A only. Right? What is the third term? Speak, speak.
A plus 2D.
Yes. What is the 100th term?
A plus 99D.
Very good. So now we are ready to move on to the next topic. So this is how we are going to calculate. This is the general term. Okay. So let's say there's a question. In an AP, the fourth term is 16. Okay. And the common difference, the common difference is of minus 4. Now we have to find out the 10th term of AP. Okay. So now first write what is given to us, that the fourth term is given. Fourth term is given, which is 16. Difference is given, which is minus 4. We have to find out T10. Okay, for finding T10, what is T10? We apply the formula A plus 90, right? So for finding the 10th term, we have to find out the first term and the common difference. Okay. So from this, as we know, what is T of 4? a plus 4 minus 1, 3d is 16. And d is given to us, which is minus of 4. So 3 into minus of 4 is equals to 16. That becomes a minus 12. So 12 goes to the right hand side. A becomes 28. Now we have A, we have D. To finding out T10, which will be A plus 9D. So A plus 9D. Now A is 28 plus 9 into D is minus of 4. Minus of 4. 28 minus 36. 28 minus 36 is what? 6 to minus of 8. Clear? Any doubt?
No, sir.
Yeah. I did a mistake in explaining. Uh, Here n, the number of terms here, the first, second, third. So the n here n is natural number. Okay, and the terms of AP can belong to real numbers. Any real number, integer, rational, irrational. Clear?
Yes, sir.
Yeah. Because the number of term, first, second, third, it's always going to be a natural number. Clear? So let's now move ahead. So we have finded out the formula of nth term, which is a plus n minus 1 into d, where a is the first term of GP, n is the number of term that we have to find out, and d is the common difference of AP, and Tn is the nth term, which we have to find out. Okay. So if we have discussed about finding out any term of the GP of the AP, we have to find out that we already know the n. We have to find out first term and the common difference. Simple. So what if we have to find out the sum of n terms? So let's go back and discuss the general form of AP, that is considering the a as the first term. So naturally second term will be a plus d. Third term will be a plus 2d. Fourth term will be a plus 3d, and the fifth term will be a plus 4d. Okay, so now what if we have to find out the sum of one element, one term only, that is simply a. We have to find out the sum of two terms, a plus d. Now what if we have to find out the sum of three terms, a plus d plus a plus 2d. So now we can write it as that this is the first term and this is the second term. And to find out the sum of three terms, we are summing all the terms. So from here, we can draw a conclusion that if we subtract S3 minus S2, that will become T1 plus T2 plus T3 minus T1 minus T2. So it will simply become T3. Okay. From here, we can draw a conclusion that the sum of n terms, when we will subtract the sum of n minus 1 terms, so it will be giving us the nth term. This is one observation. We have to note it. That the nth term will be given by s of n minus s of n minus 1. But you have to be sure that n minus 1 cannot become 0. So n has to be greater than 1. So if n has to be greater than 1, so n can be 2 or greater than 2. Okay? For this condition to state. Clear? Any doubts?
No, sir.
Yeah. Now also let's discuss about the sum of n terms formula. If we have given a and d only, and we have to find out the sum of n terms of that AP, then how we can do so? So simply we can do by this formula, s of n is equals to n of n by 2 into 2a plus n minus 1 into b. Clear? This is the formula. Important. very important. If we expand this formula and write a plus, we can write 2a as a plus a. Now this is formula of what? This is the formula of nth term.
an.
Yes. So we can write Tn or An as per your convenience. Any way you like, in whatever way you use the symbols, you can use the symbols and remember the formula. This is the sum of n terms. This is the sum of n terms formula. Clear? And there is one more formula. Sum of n terms minus sum of n minus 1 terms is the nth term. Only and only for when n is 2 or greater than 2. Clear? Any doubts?
No, sir.
Okay. So let's now discuss about the properties of arithmetic progression. And properties are always very important in the exam. Okay. So before that, let me ask you a question. Give me an example of an AP of 3 terms whose squares will also be in arithmetic progression. Can you think of any 3 numbers whose squares are also in arithmetic progression? Means if there are 3 terms like A, B, and C, and these are in AP, meaning that the common difference is D. So B minus A is D, and C minus B is also D. If we solve it further, we can write it as taking B to the left hand side, 2B taking the A as to the right hand side. 2B is equals to A plus C. Now we have to find out, and also according to the given question, A square, B square, and C square should also be AP. So for that, B square minus A square should be equals to C square minus B square. The difference between these two and the difference between these two has to be equal. So 2B square is equals has to be equals to A square plus C square. Okay, now you have to find out 3 numbers A, B, C which satisfy both of these two conditions. Can you think of any? Oh, I have asked this question incorrectly. Um, Give me an example of an AP of 3 terms uh, which are which are of 3 terms which are squares squares of natural numbers. So let me tell you the example simply. 1 square, 5 square, and 7 square. Okay, 1, 25, and 49. These 3 numbers are in AP. How? How? If we will check the difference to 25 minus 1, 49 minus 25 is 24, and this is also 24. That's why they are in AP. Clear? Any doubt?
No, sir.
Now, this is very important. Condition for three terms to be in arithmetic progression. Let's say A, B, C are in AP. So for being in AP, their difference has to be common. So B minus A has to be equal to C minus of B. Taking B to the left hand side, this becomes 2B is equals to A plus C. Now this is the sine qua non condition for being three terms that are A, B, C to be in AP. Clear? This is the condition. If this is true, ABC are in AP. If ABC are in AP, this has to be true. Clear? Any doubt?
No, sir.
Yeah. So if you have to let any three numbers who any three natural numbers whose squares are in AP, so clearly let them. When it will be required if it is mentioned that P square, Q square, and R square are in AP. Now find out PQR. Basically, if this is the question. Now we should know some three terms in AP who are like perfect square to some numbers, right? So here, as we can directly here consider that 1, 25 and 49 are perfect square numbers who are in AP. So simply P will be 1, Q will be 5, and R will be 7. So 1 into 5 into 7, that becomes 31. Easy answer, right? Okay. There was the objective. Let's now discuss about the properties of arithmetic progression. Please keep taking notes. If all terms of arithmetic progression, and I'm not forcing you to take notes. If you have already ready-made notes, then no problem. Just keep them in front of you, and whenever you think that there is something additional taught in the class, you can add them in your notes. Okay. If all terms of AP are added, let me use simple language, are added by k or subtracted from k by k or multiplied with k or divided by k being a constant, right? This is not zero, non-zero, natural number basically. Constant, basically natural number. If all terms of any AP are added by k or subtracted or multiplied or divided by the same number, then the new sequence formed, will also be in arithmetic progression. For example, let's write any AP. Let's say 4 and then 9 and then 14 and 19, 24, 29, 34, 39. If this is the AP, okay, we know this is the AP having common difference of 5. And um, if we subtract 4 from every term of this AP, if we subtract 4, so the new sequence will become 0, 5, and 10, 15, 20, 25, 30, 35. Now this is this particular new sequence is also an AP with of course different common difference for sure. Now the common difference here is 5, but if it would have getted multiplied or divided, then for sure the common difference was going to change. But my point is that the sequence nature will remain of the same. This is still an AP. Clear? Any doubts?
No, sir.
Yeah. So if all the terms of an AP are getting added or subtracted or multiplied or divided by the same number, then the new sequence is also going to be an AP. Let's move forward and discuss the second property, which says in a finite AP. Now tell me what is a finite AP? Arithmetic progression having limited number of terms. Okay, anyway, let's move forward. In a finite AP, let me give you a direct example. Why? What's the point? The point is if the sum of number of terms is same on either side, on both sides, on both sides. Okay, this will not be the true. This will not be true. There will be three A's here. There has to be two terms only, then only it's going to be true. If there are two terms in this side, there has to be two terms also in this side. 3 plus 6 is what? If this is the case, then it's definitely going to be true. Why? Why? Because this will become a plus d. The seventh term is a plus 6d. The first term is a. The eighth term is a plus 7d. The third term is a plus 2d. The sixth term is a plus 5d. Okay, now calculate. This becomes 2a plus 7d. This becomes 2a plus 7d. This becomes 2a plus 7d. Okay, this is the logic behind. So if there are like same number of terms on both sides and the number, the n, is getting added to equal. So they are going to be equals, sum of equals, sum of equal pairs. Clear? Any doubt? So we can generalize it and write it like if there is any term k getting added any term, any other term, then it can be rewritten as a1 plus an. Why? The sum between these two is k plus n minus of k plus of 1. So basically the sum is n plus 1 here. The sum here is also n plus 1. This is one generalized form. You can learn by this from this example also. Basically, you have to remember what the conclusion is. Clear? Any doubts?
No, sir.
Okay, let's move forward. Third property says, this is basically, we'll discuss it later. Let's move on to the other property. Third property. If all the terms of an AP are chosen at regular interval. So let's take an example of an AP. Having first term as 2, common difference is 4. Positive difference. If there are these many, like there are a lot of terms, and if we pick any terms from at a regular interval, let's say after interval of two terms, we are going to pick a term. So one term picked, then after two terms we pick another, and then after two we pick another, then after two we pick another. So this become 2, 14, 27, 38. Now my point is, if this was an AP, if terms are picked on a regular interval, then the new sequence formed, the new sequence formed will also be an AP. Let's check. The difference between these two is 12. Difference between these two is also 12. Difference between these two is also 12. If the common difference between any two consecutive terms is same, then it is an AP. Clear? This is the property. Clear? Any doubts?
No doubt, sir.
Let me write it also. If all terms of an AP are chosen at regular interval, then the new sequence formed will also be an AP. Clear?
Yes, sir.
Okay, let's move on to the next. Now, this is not a property actually, but this is more of like a result, observation result, and it would be helpful for you to remember it. So, if there is any AP of the form where general term is Pn is equals to P of n plus Q. The nth term is Pn plus Q. So now the difference here is P, and the first term, that is A, is P plus Q here. Clear? So
Yes,
if there
sir.
is any AP of the form where the sum of n terms is an square plus bn, then the difference, or the common differences of 2a, the first term will be the sum of one term, that is n is equals to a, so it becomes a plus b. Clear?
Yes, sir.
Doubts? So let's take few examples. For example, if there is an AP in the form 2n plus 5, and you have to find out simply 10th term. What will you do? Any steps? Guru, Charan and Yalini?
Using the Tn is equal to 2n plus 5, sir.
Uh-huh. But how will
We have to substitute 10 in the n place.
okay. Very 20 plus 5, that becomes 25. If we have to find out the d, then it is simply the coefficient of n. If we have to find out the first term, clear? Let us say sum of n terms is 5n square minus of 2n. Now, tell me what is the common difference and what is the first term? The result is written there in front of you. You can use that.
A is equal to 23, sir.
A is equals to 23. Sum of one term is
Oh,
equals to the first term itself. So 5 into 1.
no, then it's 3. Sorry, sir.
Yep, is 3. Now the difference is the twice of the coefficient of n square, which is 10. Okay. So if we have A and D, we can write the AP. Okay. Clear? Any doubts? Any doubts?
No, sir.
Let's move forward to the next statement, which says if it is given to us that the nth term, sorry, the pth term is q and the qth term is p, then the p plus qth term will be 0 and the nth term, can we find it out by? Can we find it out by p plus q minus of n? P plus q minus of n. But this kind of question will not be asked directly, but this result may be indirectly used in any solution anywhere as these conditions are getting satisfied. These are the conditions. Okay. Clear?
Yes,
Any
sir.
doubt?
No, sir.
So there is one question. If second term is equals to 3 and third term is equals to 2, then what is A5 and what is A10? Tell me. Given that this sequence is of AP. A5 is 2 plus 3, right? So P plus QH term will be 0. A5, the fifth term is 0. Clear. Now nth term can be written as P plus Q minus of n. P plus Q is 2 plus 3 minus of n is 10 here. So its answer is minus of 5. Clear? Any doubts?
No, sir.
Basically, what was asked from us was P plus Q. Now, the gist is not, you don't have to learn P and Q. It's that what is P and Q? What is the relevance of P and Q in the property? Is that pH term was Q. The QH term was P. Now, these were two numbers which we were referring to as P and Q. Now, in the question given to us that the second term is 3, the third term is 2. Now, 2 plus 3, the 2 plus 3th term, that is the fifth term, will be 0. And we have to find out any other nth term. Then we'll be simply uh, subtracting the n from 2 plus 3. Clear?
Yes, sir.
Moving to the next property, which says if the sum of pth term, the sum of p term, sorry, if the sum of p terms is q and sum of q terms is p, then the sum of p plus q terms will be equals to minus of p plus q. Let's say if the sum of two terms, example, is 3, the sum of two terms, sorry, and the sum of three terms is 2, and the sum of five terms will be minus of 2 plus 3, that is minus of 5. Clear? Any doubts?
No, sir.
Yeah. So, shall we cross check it? Okay. So let's say the sum of two terms can be written as a plus d. First to three. Sum of three terms is a plus d, and a plus 2d. First to two. Sum of five terms. Okay, anyways, let's solve this first. 2a plus d becomes 3. Now 3a plus 3d becomes 2. Which says a plus d becomes 2 by 3. Yes. So now we have these two equations. 2a plus d becomes equals to 3. So let's now substitute the value of d from the this from this we can write 2 by 3 minus of a is d. Okay, so 2a plus d is 2 by 3 minus of a equals to 3. So we can write it as 2a minus a is equals to a, 3 minus of 2 by 3, that becomes 9, minus 2, 7 by 3. So the a is, so the first term is 7 by 3 here, and the difference is 2 by 3 minus 7 by 3. That becomes minus 4 by 3. Difference is minus 4 by 3. Okay. If we subtract minus 4 by 3 from there, here, so it will become 3 by 3, that is this. If we further subtract minus 4 by 3, that becomes minus 1 by 3. And if you further do it, then it becomes minus of 5 by 3. If you further do it, minus 9 by 3. So these are the 5 terms. So if we sum all of these, then the LCM will be 3. 7 plus 3 becomes 10. 10 minus 1 minus 5 minus 9. So minus 1 minus 9 cancel 10. So this becomes minus of 5 by 3, which is contradicting here. Okay. Let's see why have we done any mistake or what. And the sum of two terms was 3. 2a plus d was 3. 2, okay. And the sum of three terms was 2. So the first term, second term, third term. 3a plus 3d becomes 2. A plus d becomes 2 by 3. Okay. And now 2a, d becomes 2 by 3 minus a. So 2a plus 2 by 3 minus of a is equals to 3. Okay. Okay. Now a plus 2 by 3 is equals to 3. A becomes 3 minus of 2 by 3. So that becomes 3 into 3, 9 minus 2, 7 by 3. Clear. Now d becomes 2 by 3 minus of 7 by 3. Now that should become minus of 5 by 3. So if 7 by 3 is the starting, so it will become 2. Then 2 minus 5 will become minus of 3. Then it should become minus 8 by 3. Then it should become minus 13 by 3. Now taking LCM as 3. 7 plus 2 becomes 9, minus of 3 minus of 8 minus of 13. 9 minus 3 becomes 6. Okay, plus 6 minus 8 becomes minus 2. That becomes minus of 15. Minus of 15 by 3, that becomes minus of 5, which confirms with their answer. So these many calculations, this was a long method that we had to use if we didn't use this property. Clear?
Yes, sir.
Yeah, that was very tedious task to do. That's why these properties and results are being told. Okay. So this is all about the properties of arithmetic progression, and there's also one more, convenience assumption. Let me say it first. So if it is being told and if it is the requirement of the question to assume any three terms, okay. Now in AP we have two variables. In AP we have two variables, that is A and D. If we have to assume three terms, then we may do so by A minus of D, A and A plus of D. The common difference is of 2 everywhere. We have to assume four terms, then we have to do something different in assume terms with difference of 2D. The difference between all of these terms are 2D. Now, why particularly we are doing so? Because After summing all of these even terms, we will get 4 of A. Here the sum is 3 of A. There are 5 terms to be assumed. So simply assume A minus 2D, A minus D, A plus D, A plus 2D. No problem. But whenever we talk about even terms, then we have to go for the difference of 2D. Okay. So 3 and A plus 5D. So now there are 6 terms. Okay. The convenience is the sum of all is 6A. The sum of all is 5A. The sum of all terms is 4A. Okay. So if we have to deal with the sum, we don't have to deal with two variables. We'll left with only one variable, that is A. Clear? Any doubts?
No, sir.
Okay. So let's conclude our class here. Any doubts, anyone? Any questions regarding preparation or anything else?
No, sir.
Good then. Thank you, Janin.
Thank you, sir.